Transportation is one of the main ways that humans expend energy. We all need to go places to work, play, or visit. The way we choose to travel has a large impact on the planet. In this chapter, we will learn about the state of transportation around the world, the impacts of different transportation options, and innovative approaches to reducing the environmental and societal impact of transportation on society in general. There are numerous modes of transportation that contribute to the emissions of greenhouse gases. We will take a look at how each mode of transportation affects the world. We start the conversation with the obvious mode that is cars. Since the 1950s, the number of automobiles has considerably increased, especially in developed countries. Motorization significantly reduced the number of people per automobile from 48.2 in 1950 to 7.15 in 2019. There are consequently more vehicles per capita, which is a good indicator of potential mobility. In 2017, the global registered automobile fleet was estimated to have surpassed 1 billion vehicles for the first time, with annual car production in the range of 60 to 70 million vehicles. There are more registered vehicles in the United States than there are licensed drivers. Along with the number of vehicles and their production, the distance traveled per vehicle is also rising. Each passenger vehicle travels about 12,500 miles annually in the United States, up from about 9,000 miles in 1980. This growing mobility reflects ongoing spatial changes in terms of size and density of urban areas. However, as the example of the United States illustrates, peak mobility can be reached as the average mileage per car has not changed and even dropped since the 2000s. The 1.49 billion cars on the road will emit 6.9 billion metric tons of carbon dioxide into the atmosphere this year. To put that in perspective, that's equivalent to burning all of the coal in a fully loaded coal train that stretches 347,000 miles, long enough to wrap 13.9 times around the Earth at the equator. After 10 years of continuous growth, world auto production saw a significant decline in 2019, with global production decreasing more than 5% for the year. In 2019, manufacturers produced approximately 92 million vehicles worldwide, including 67 million cars and 25 million commercial vehicles. The decline in automobile production continued well into 2020 as manufacturing shut down due to the overall economic crisis that began in March that year. The cumulative data from January 2020 through September of 2020 showed a 22.9% decrease in global automobile production compared to the same period in 2019. China, well known as the world's biggest manufacturer, is the leading producer of cars. The country's 2019 production resulted in the completion of almost 26 million motor vehicles, or about 28% of all cars and trucks produced. Approximately 83% of China's production went towards making personal passenger cars, while the other 4.3 million vehicles produced were for commercial use. With sales of 6.2 million vehicles in 2019, SAIC Motor Corporation Limited is the largest manufacturer of vehicles in China. The United States produced only 11 million cars and trucks in 2019, but still it is the second largest manufacturer in the world with just under 12% market share. Although its production of passenger cars was less than Japan and Germany, the United States produced almost twice as many commercial vehicles as any other country, including over 5 times as many as Japan. General Motors Company had the greatest market share of automobiles sold in the United States with 17.4%. Ford Motor Company and Toyota Motor Company held 14.5 and 13.9% of the U.S. automobile sales market, respectively. Japan produced 9.7 million total vehicles in 2019, or approximately 10.5% of all vehicles made globally. The country manufactured 8.3 million passenger cars and approximately 1.4 million commercial vehicles. In 2017, Japan exported 4.71 million cars, trucks, and buses. This number increased by 2.3% in 2018 when the country exported 4.82 million vehicles. In 2019, exports remained flat with the nation exporting 4.82 million vehicles. For the first three quarters of 2020, Japanese auto companies manufactured 5.7 million vehicles, down 22.8% compared to the 7.4 million vehicles manufactured during the first three quarters of 2019. Top German automakers, including Volkswagen AG, BWM AG, and Daimler AG, produced approximately 4.7 million total cars in 2019. This figure represented a 9% decrease from 2018 production levels and a 17.4% decrease from 2017 production levels. German car lobby firm VDA cited decreasing demand from international markets as a prime reason for the falling numbers. As of August 2020, Germany had manufactured approximately 2 million passenger cars for the first 8 months of 2020, down 36% to the same period in 2019. The drop in manufacturing was blamed on the decrease in the number of working days and shutdowns caused by the global pandemic. While not well known in America or Europe, India makes vehicles for its population of over 1.3 billion people. India produced 4.5 million total vehicles in 2019, which represented a year-over-year decline of 12.2%. Approximately 80% of manufactured vehicles were passenger cars and 20% were commercial vehicles. For the first three quarters of 2020, auto companies in India manufactured approximately 2.16 million vehicles, down 38.4% compared to the 3.5 million vehicles manufactured during the first three quarters of 2019. In 2019, Mexico manufactured 1.38 million passenger cars and 2.6 million commercial vehicles for a total of 3.9 million vehicles. This represented a year-over-year decline of 2.8% compared to 2018. Trucks are a major contributor to the growth in transport fuel consumption, as well as rising carbon dioxide and air pollutant emissions. But the sector gets far less attention and policy focus than passenger vehicles. Only 4 countries have energy efficient standards for heavy trucks, compared to about 40 countries with passenger vehicle standards. America's trucks travel a total of 93,512,000,000 miles per year. That's over 1,000 times the distance from the Earth to the Sun. Most trucks get about 8 gallons per mile, so that works out to almost 6 million tons of carbon dioxide per year. Trucking may not technically be the most environment-friendly way to ship freight. By almost any measure, carbon emissions, other pollutants, noise, and accidents, rail or water is better. But there are places rail and water simply cannot go. For the foreseeable future, trucking's market share is likely to grow. Trucking is already shrinking its carbon footprint by progressively improving fuel efficiency. Large truck fleets have the option of shifting to alternative fuels such as biodiesel, since they can invest in their own new infrastructure. Biodiesel releases almost as much carbon dioxide as traditional diesel fuel does, but because it is made from plant matter, its carbon content came out of the atmosphere recently. Sending that carbon back into the sky does not change the overall balance of the atmospheric gases. Electric car markets are seeing exponential growth as sales exceeded 10 million in 2022. A total of 14% of all new cars sold were electric in 2022, up from around 9% in 2021 and less than 5% in 2020. 3 markets dominated global sales: China was the front runner once again, accounting for around 60% of global electric car sales. More than half of the electric cars on the road worldwide are now in China, and the country has already exceeded its 2025 target for new energy vehicle sales. In Europe, the second largest market, electric cars sales increased by over 15% in 2022, meaning that more than one in every five cars sold was electric. Electric cars in sales in the United States, the third largest market, increased 55% in 2022, reaching sales share of 8%. Electric car sales are expected to continue strongly through 2023. Over 2.3 million electric cars were sold in the first quarter, about 25% more than the same period last year. It is expected to see 14 million in sales by the end of 2023, representing a 35% year-on-year increase, with new purchases accelerating in the second half of this year. As a result, electric cars could account for 18% of total car sales across the full calendar year. National policies and incentives will help bolster sales, while a return to the exceptionally high oil prices seen last year could further motivate prospective buyers. There are promising signs for emerging electric vehicle markets, albeit from a small base. Electric car sales are generally low outside the major markets, but 2022 was a growth year in India, Thailand, and Indonesia. Collectively, sales of electric cars in these countries more than tripled compared to 2021, reaching 80,000. For Thailand, the share of electric cars in total came in at slightly over 3% in 2022, while both India and Indonesia averaged around 1.5% last year. In India, electric vehicles and component manufacturing is ramping up, supported by the government's $3.2 billion incentive program that has attracted investments totaling $8.3 billion. Thailand and Indonesia are also strengthening their policy support schemes, potentially providing valuable experience for other emerging markets economies seeking to foster electric vehicle adoption. The European Union and the United States have passed legislation to match their electrification ambitions. The European Union adopted new CO2 standards for cars and vans that are aligned with the 2030 goals set out by the UN. In the United States, the Inflation Reduction Act, combined with the adoption of California's Advanced Clean Cars rule by a number of states, could deliver a 50% market share for electric vehicles in 2030, in line with the national target. The implementation of the recently proposed emission standards from the US EPA is set to further increase this share. Battery manufacturing continues to expand, encouraged by the outlook for electric vehicles. As of March 2023, announcements on battery manufacturing capacity delivered by 2030 are more than sufficient to meet the demand implied by government pledges, and would even be able to cover the demand for electric vehicles in the net zero emissions by 2050 scenario. It is therefore well possible that higher shares of sales are achievable for electric cars than those anticipated on the basis of current government policy and national targets. The increase in demand for electric vehicles is driving demand for batteries and related critical minerals. Automotive lithium-ion battery demand increased by about 65% in 2022. In 2022, about 60% of lithium, 30% of cobalt, and 10% of nickel demand was for electric vehicle batteries. Only 5 years prior, these shares were around 15, 10, and 2% respectively. Reducing the need for critical minerals will be important for supply chain sustainability, resilience, and security, especially given the recent price developments for battery material. New alternatives to conventional lithium-ion are on the rise. The share of lithium iron phosphate chemistries reached its highest point ever, primarily driven by China. Around 95% of the lithium iron phosphate batteries for electric vehicles went into vehicles produced in China. Supply chains for lithium-free batteries are also being established with over 100 gigawatts of manufacturing capacity either currently operating or announced, almost all in China. The electric vehicle supply chain is expanding, but manufacturing remains highly concentrated in certain regions, with China being the main player in the battery and electric vehicle component trade. In 2022, 35% of exported electric vehicles came from China, compared with 25% in 2021. Europe is China's biggest trade partner for both electric cars and their batteries. In 2022, the share of electric cars manufactured in China and sold in the European market increased by 16%, up from about 11% in 2021. Electric vehicle supply chains are increasingly at the forefront of electric vehicle related policy making to build resilience through diversification. The Net Zero Industry Act proposed by the European Union in 2023 aims for nearly 90% of the European Union's annual battery demand to be met by European Union battery manufacturers with a manufacturing capacity of at least 550 gigawatt hours in 2030. Similarly, India aims to boost domestic manufacturing of electric vehicles and batteries through production-linked incentive schemes. In the United States, the Inflation Reduction Act emphasizes the strengthening of domestic supply chains for electric vehicles, electric vehicle batteries, and battery minerals, laid out in the criteria to qualify for green vehicle tax credits. As a result, between August of 2022 and March 23, major electrical vehicle and battery makers announced cumulative post Inflation Reduction Act investments of at least 52 billion in North America electric vehicle supply chains, which is 50% for battery manufacturing and about 20% for battery components and electric vehicle processing. Autonomous driving could revolutionize the way consumers experience mobility. Autonomous driving systems may make driving safer, more convenient, and more enjoyable. Hours on the road previously spent driving could be used to video call a friend, watch a funny movie, or even work. For employees with long commutes, driving in an automated vehicle might increase worker productivity and even shorten the workday. Since workers can perform their jobs from an autonomous car, they could easily move farther away from the office, which in turn could attract more people to rural areas and suburbs. Autonomous driving might also improve mobility for elderly drivers, providing them with mobility options that go beyond public transportation or car sharing services. Department of Transportation researchers estimate that fully autonomous vehicles could reduce traffic fatalities by up to 94% by eliminating those accidents that are due to human error. Using 2016 numbers as a baseline and multiplying 37,461 by 10, this means there could be 374,610 deaths in a 10-year span, and 94% of these, or 352,133, could possibly be prevented through fully autonomous cars by eliminating driver error. There are several limitations and barriers that could impede adoption of autonomous vehicles, including the need for sufficient consumer demand, assurance of data security, protection against cyber attacks, regulations compatible with driverless operation, resolved liability laws, societal attitude and behavior changing regarding distrust and subsequent resistance to autonomous vehicle use, and the development of economically viable autonomous vehicle technologies. Here are some of these drawbacks to automated vehicles. First are security issues. One of the potential cons about self-driving cars is the possibility of hacking. To have automated cars talk and coordinate with each other, they would need to share the same network protocol. If a large number of cars share the same network, however, there could be susceptible to a hack. Even a small hack could wreak significant damage on busy roads by causing collisions and gridlock traffic. The next would be job losses. Those who depend on driving to make a living may find their career obsolete with the introduction of self driving cars. Those in the trucking industry, bus drivers, taxi drivers will all need to find new employment. Fast food delivery and Uber drivers would also find themselves replaced by automated cars. Another con is the initial costs. While self driving cars may produce significant societal cost savings in the long term, the initial cost of automated vehicles may be astronomical. Some experts estimate it could cost an additional $250,000 per vehicle to own a fully autonomous vehicle. Of course, as new technology matures, costs should come down. In the early stages, however, the barrier to entry may be too high for the general population. Another con is the moral machine dilemma. Another of the disadvantages to self driving cars is their lack of ability to make judgments between multiple unfavorable outcomes. For example, what if a self driving car had to face a situation with only two possible options? First, veering to the left and striking a pedestrian, or veering to the right and hitting a tree, potentially injuring passengers inside your vehicle. Since both options are undesirable, which option would the autonomous car choose? The Moral Machine, developed by a group at MIT, is seeking to address this issue by collecting data on real life people's decisions. However, the data collected shows broad differences among different people groups, making it difficult to program any definitive answer for autonomous cars. Finally, machine error. Machine error must be taken into consideration when examining the pros and cons of driverless cars. While most agree self driving cars will likely prevent more accidents from happening, it does not completely eliminate risks of accidents caused by machine error. Furthermore, if the software or any part of the vehicle fails, an autonomous vehicle could put the driver in more danger than if the driver was to personally take control of the vehicle. Rail is among the most energy efficient modes of transport for freight and passengers. While the rail sector carries 8% of the world's passengers and 9% of global freight transport, it represents only 3% of total transport energy demand. Today, three-quarters of passenger rail transport activity takes place on electric trains, which is an increase from 60% in 2000. The rail sector is the only mode of transport that is widely electrified today. This reliance on electricity means that the rail sector is the most energy diverse mode of transport. The regions with the highest share of electric train activity are Europe, Japan, and Russia, while North and South America still rely heavily on diesel. Passenger rail is significantly more electrified than freight in almost all regions, and regions with high reliance on urban rail and high-speed rail are those with the largest share of passenger miles served by electricity. Conventional rail covers medium to long distance journeys with a maximum speed under 155 miles an hour and suburban train journeys. Most conventional rail networks are located in North America, Europe, China, Russia, India, and Japan. These regions make up about 90% of global passenger movements on conventional rail, with India leading at 39%, followed by China at 27% and Japan at 11%, and the European Union at 9%. However, conventional rail has shown little change across these regions over the past decades. In contrast, significant investments have been made in high-speed rail and metros. High-speed rail is defined as rail services over long distances between stations operating at a maximum speed above 155 miles an hour. Metro rail refers to high-frequency, high-capacity urban services which are fully separated from traffic, often underground or elevated, and light rail to tramways and other lower capacity, lower speed urban transport systems, most often at the street level. High-speed rail provides an important alternative to aviation, while urban rail provides a solution to cities impacted by congestion and air pollution. Growth has been most notable in China, which has overtaken all other countries in terms of network length in both types within a single decade. The future of rail will be determined by how it responds to both rising transport demand and rising pressure from competing transport modes. Rising incomes and populations in developing and emerging economies where cities are growing exponentially are set to lead to strong demand for more efficient, faster, and cleaner transport, but the need for speed and flexibility tend to favor car ownership and air travel. Rising incomes also drive demand growth in freight, where higher incomes have sharply increased demand for rapid delivery of higher value and lighter goods. The rail sector has an important advantages to exploit in competing for business, but this will require additional strategic investments in rail infrastructure, further efforts to improve commercial competitiveness, and technological innovation. As the world transitions to green energy, sustainable infrastructure is becoming increasingly essential. Railway transportation, in particular, is a major contributor to green carbon dioxide emissions. So, finding ways to reduce its environmental impact has become more important than ever. As a result, engineers worldwide are coming up with new ways to build efficient and good railways for the environment. Today's railway systems increasingly use automated technologies, offering new possibilities. For example, it can help monitor train traffic and make it easier to track, and also help reduce the carbon footprint of high range rail equipment. As a result, railways can take important steps towards preserving our planet by ensuring that the release of pollutants is kept to a minimum. Plus, automating the monitoring of fuel consumption allows them to save money on wasted resources. Traditional materials such as concrete and wood take a long time to decompose and contribute to pollution. That's why railways are now shifting their focus to using recyclable materials like steel and aluminum. These materials can be reused or recycled with minimum environmental impact. It can make a huge difference over the long run if we use recyclable materials more in our railway constructions. Railways are always looking for ways to reduce their impact on the environment. One way is to use lightweight parts. These components can help reduce the train's weight from composite materials to lighter metals. Not only does this help save fuel, but it also reduces the amount of wear and tear on the tracks and lowers maintenance costs. The world fleet that carries seaborne trade involves dry bulk ships, container ships, and oil tankers. Each vessel type specializes in different classes of products and can be split into two categories: those that operate on fixed itineraries, much like buses, and those that operate on flexible routes, much like taxis. Container ships belong to the first group, while oil and gas tankers and dry bulk ships to the second. Dry bulk ships, which account for about half of seaborne trade and 45% of total world fleet, are the main mode of transportation for commodities such as grain, ore, and coal. They operate on flexible routes and therefore are called ocean taxis. Some 11 billion tons of goods are transported by ship each year. This represents an impressive 1.5 tons per person based on the current global population. Shipping's capacity to transfer goods and materials from where they are produced to where they will ultimately be consumed underpins modern life. Each year, the shipping industry transports nearly 2 billion tons of crude oil, 1 billion tons of iron ore, which is used to make steel, and 350 million tons of grain. These shipments would not be possible by road, rail, or air. Such raw materials allow countries to create industries, construct cities, house and move populations, and transform resources into refined products for re-export. This ability to add value drives prosperity and enables developing countries to scale up. Large volumes of other key products such as chemicals, refined fuels, and manufactured goods are also shipped by sea. To support world economy, shipping has developed highly sophisticated logistic chains, developing just-in-time parts and goods to manufacturers and consumers. Avocados, for example, are shipped from Chile to arrive in America just as they ripen. What opportunities exist to make shipping more sustainable? The following is a list of ideas for doing just that. First, promote the adoption of enforceable speed limits and speed reduction in areas with high levels of marine animal ship strikes and populations of endangered marine animals. Slower ship speeds also reduce greenhouse gas emissions, reduce air pollution, lower fuel consumption, and increase safety on board. Next, increased investment in sustainable propulsion methods for ships, including, but not limited to, sails, high altitude kites, and electric supplemented propulsion systems. Better navigation systems may provide optimum route navigation to avoid hazardous locations, find key fishing areas, track animal migrations to reduce impacts, ensure regulation compliance, and reduce the time a ship is at sea and thus reduce the time the ship is polluting. Develop or provide sensors that can be used to collect ocean data. Ships that automatically gather water samples can provide real-time monitoring and chemistry testing to help fill in knowledge gaps about ocean conditions, currents, changing temperatures, and ocean chemistry changes. Create GPS networks to allow ships to tag large accumulations of microplastic, ghost fishing gear, and marine debris. The debris could either be picked up by authorities and non-governmental organizations or collected by those in the shipping industry itself. Integrate data sharing that supports partnerships between those in the shipping industry, scientists, and policymakers. Work to implement new, stricter international standards on ballast water and wastewater treatment to combat the spread of invasive species. Promote extended producer responsibility where end-of-life plans are considered from the initial design of ships. Flying is a highly controversial topic in climate debates, and there are a few reasons for this. The first is the disconnect between its role in our personal and collective carbon emissions. Air travel dominates a frequent traveler's individual contribution to climate change, yet aviation overall accounts for only 2.5% of global carbon dioxide emissions. This is because there are large inequities in how much people fly. Many do not or cannot to afford to fly at all. The second is how aviation emissions are attributed to countries. CO2 emissions from domestic flights are counted in a country's emission accounts. International flights are not. Instead, they are counted as their own category, bunker fuels. The fact that they don't count towards the emissions of any country means that there are few incentives for countries to reduce them. Aviation accounts for about 2.5% of global CO2 emissions, but its overall contribution to climate change is higher. This is because air travel does not only emit CO2, it affects the climate in a number of more complex ways. As well as emitting CO2 from burning fuel, planes affect the concentration of other gas and pollutants in the atmosphere. They result in a short-term increase but long-term decrease in ozone, a decrease in methane, emissions of water vapor, soot, sulfur aerosols, and water contrails. While some of these impacts result in warming, others induce a cooling effect. Overall, the warming effect is stronger. Aviation's contribution to climate change, 3.5% of warming or 2.5% of emissions, is often less than people think. It's currently a relatively small chunk of emissions compared to other sectors. The key challenge is that it is particularly hard to decarbonize aviation. There are solutions to reduce emissions for many of the largest emitters, such as power or road transport, but it is a matter of scaling them. We can deploy renewable and nuclear energy technologies and transition to electric cars, but we don't have proven solutions to tackle aviation yet. Liftoff is usually the most environmentally harmful stage of any space mission, with vast quantities of fuel burnt up in a matter of minutes. For instance, SpaceX's Falcon 9 goes through 112 tons of refined kerosene, emitting about 336 tons of carbon dioxide, the equivalent produced by your average car driving almost 70 times around the world. As well as greenhouse gases, rocket engines emit chlorine and particles of soot and aluminum oxide that destroy ozone. These issues are growing more pressing with the advent of commercial spaceflight. There were 114 space launches in 2020, but there may be up to 1,000 per year in the future. Sustainable fuels are at the top priority to enable greener space travel. Current spacecraft use a variety of fuels, but most are based on fossil fuels. One potentially greener option is liquid hydrogen and oxygen used by the New Shepard propulsion module from private spaceflight company Blue Origin. Hydrogen can be obtained sustainably by using solar power to break water down into oxygen and hydrogen molecules. In 2019, NASA's Green Propellant Infusion mission road tested a type of green alternative to hydrazine, which is a toxic component of many types of rocket fuel, with the hopes to use this to power future missions. Reusable rockets can cut down on some of the waste associated with spaceflight. Traditionally, boosters, fuel tanks, and other components are treated as expendable, but guiding them back to Earth in a controlled manner opens new possibilities. Most components from the Falcon 9 can be reused up to 100 times. Truly environmentally friendly space travel is still some ways off, but we already have many of the technologies needed to start limiting its impact on the planet. This slide shows an example of the new rockets being used by the SpaceX company. The Dragon spacecraft is capable of carrying up to 7 passengers to and from Earth orbit and beyond. It's the only spacecraft currently flying that is capable of returning significant amounts of cargo to Earth, and it is the first private spacecraft to take humans to the space station. In 2020, SpaceX returned America's ability to fly NASA astronauts to and from the International Space Station on American vehicles for the first time since 2011. In addition to flying astronauts to space for NASA, SpaceX's Dragon spacecraft can also carry commercial astronauts to Earth orbit, to the International Space Station, or beyond. Motor vehicle traffic and its accompanying pollution have been a major environmental concern for decades. With approximately 1.2 billion vehicles in operation today and more on the way, Earth's atmosphere continues to absorb massive amounts of harmful emissions from a billion internal combustion engines on a daily basis. However, the problems don't end with emissions. Roads and parking lots have greatly expanded to accommodate the growing number of vehicles, creating another series of problems. The materials used, primarily asphalt and concrete, negatively impact the environment in three ways. First, they deplete resources. Asphalt is a petroleum-based product. Concrete requires rock, sand, and fabricated cement component to strengthen the material and hold the pavement together. Drilling, mining, processing, and applying these materials to the roadway are resource-intensive processes. Fortunately, industry innovation has led to meaningful progress towards resource conservation. Road construction companies have developed ways to reuse existing concrete and asphalt by remixing it with virgin materials. While this reduces resource depletion, producing asphalt and concrete still uses considerable amounts of energy. Second, they pollute water. Road and parking lot projects usually require elaborate drainage networks to remove rainwater from surfaces and prevent flooding. Flowing over pavement exposes water to pollutants, surface debris, and asphalt. This polluted water eventually flows into municipal sewage networks, which empties into lakes, streams, and rivers. Third, they generate harmful atmospheric emissions. Petroleum-based asphalt is a high VOC or volatile organic compound substance. As the product is converted to asphalt, significant quantities of harmful gases are released into the atmosphere. Likewise, the process of producing cement for concrete requires high levels of heat and generates substantial VOC emissions. The application and curing of the applied asphalt add even more harmful materials to the air. Additionally, some areas still use high VOC paints for striping roads and parking lots, adding another unsustainable element to the process of road and parking lot construction. To minimize the depletion of Earth's resources, paving companies have developed technology to reuse and recycle asphalt and concrete materials. One system allows the equipment to strip and rework existing pavement before applying it to the same roadbed. As a partial solution to the water drainage issue, roadway engineers are developing and testing porous concrete and asphalt that allows water to drain through the material into the ground below. The initial challenge with this technology was making the porous material sufficiently durable for mass roadway consumption, but this has been accomplished by recent innovations. As for reducing atmospheric damaging high VOC striping and marking paints, a company called BioStripe produced a high quality bio-based paint for striping roadways and parking lots. Produced from renewable soybean oil, BioStripe provides sustainable line striping solution while minimizing environmental impact. Approximately 85% of greenhouse gas emissions from the transportation sector are related to surface transportation systems. Public transportation use is one of the most effective actions individuals can take to conserve energy. Riding public transportation far exceeds the benefits of other energy-saving household activities such as using energy-efficient light bulbs, adjusting thermostats, or using high-efficiency appliances. A single person who switches from a 20-mile commute alone by car to existing public transportation can reduce their annual CO2 emissions by 20 pounds per day, more than 48,000 pounds in a year. That is equal to 10% reduction in all greenhouse gases produced by a typical two-adult, two-car household. By eliminating one car and taking public transportation instead of driving, a savings of 30% of carbon dioxide emissions can be realized. U.S. public transportation saves 37 million metric tons of carbon dioxide annually, equivalent to the emissions resulting from the electricity generated for the use of 4.9 million households, or every household in Washington, D.C., New York City, Atlanta, Denver, and Los Angeles combined. Let's take a deeper look into the different types of mass transit, including railways, light rail, buses, and ferries. It's an almost universally accepted assumption that taking the train is much better for the environment than taking a car. After all, a train can hold many more passengers at the same time, whereas if you travel by car, you're usually taking an individual vehicle. But does this assumption actually hold up to scrutiny? If we take an overall view of the transport sector, 71% of transportation-related carbon emissions comes from road users, whereas only 1.8% of emissions stem from rail travel. So in absolute terms, trains are responsible for a lot less emissions than cars. While trains are also becoming more environmentally friendly with time, such as electric trains are now commonplace, one other factor to consider is the lifespan of these different modes of transport. Cars tend to be renewed a lot more frequently than trains, for example. Trains, on the other hand, are built to last several decades. This means that a train that was built 5 years ago is still likely to be in use 10 to 20 years from now. The result of this is that transitioning to more efficiency models takes a long time in comparison to the quick pace of the car industry. With rapid population growth and urbanization, the need for alternative transportation services of societies has increased gradually in recent decades. When economies develop and cities sprawl, the contribution of transport to environmental problems, illness, and death increases sharply worldwide. Particularly in large cities, problems related to transport reach high levels due to high energy consumption, environmental pollution, and traffic congestion. Approximately 25% of global energy consumption and carbon dioxide emissions are related to the transportation sector. In the transportation sector, road transportation is responsible for 76% of the total global oil consumption, whereas the share of rail transportation is 0.6. Thus, policymakers and researchers have made significant efforts to explore how low cost and environmentally friendly transportation alternatives can reduce negative impacts and the dependence on petroleum fuels. In recent years, cities have had a greater need for railway systems, particularly for urban and intracity transportation due to population growth. In particular, cities with a population greater than 1 million will need thousands of kilometers of railway infrastructure and hundreds of railway vehicles within the next few years. Various urban railway transportation modes, such as metros and light railway systems, are utilized in some cities because they are more environmentally friendly, comfortable, and economically feasible than buses, minibuses, and metro buses. America's bus network plays a crucial role in the lives of millions of people, providing transport for those who cannot or do not wish to drive, and carry up to half of all American children to and from school every day. The majority of America's buses, however, are still powered by polluting fossil fuels such as diesel that pose serious risks to public health and contribute to global warming. Battery-operated electric buses can reduce the environmental and health threats posed by diesel buses, while also providing a reliable and cost-effective option for cities and school districts. Advances in electric bus technology and rapid decline in battery costs over recent years have made electric buses an increasingly viable option for many transit agencies and school districts. However, electric buses are still an emerging technology. Transit agencies and school districts considering electric buses need to know what to expect, and more importantly, how to get the greatest benefit from their investment. Electric buses deliver numerous benefits to the communities they serve, including the following. First, by eliminating diesel exhaust emissions, particulate pollutions, and pollutants that contribute to the formation of ground level ozone, they improve air quality in our communities. Second, they produce significantly lower greenhouse gas emissions than diesel hybrid, and natural gas powered buses. Replacing all of the country's diesel-powered transit buses with electric buses could eliminate more than 2 million tons of greenhouse gas emissions each year. Third, electric buses can deliver financial benefits, including substantial reduced maintenance costs, and in places where utility rate policies are favorable, reduce fuel costs. Fourth, by reducing air pollution, electric buses can also deliver significant societal benefits, including avoided healthcare expenses resulting from cleaner air. Increasing regional mobility demand amid rising roadway congestion has motivated plans for passenger ferry expansion and modernization in many parts of the U.S. While this trend applies to ferry systems in Alaska, New York, Boston, and Washington state, new efforts to expand ferry service in San Francisco Bay Area are also underway. Integrating ferry service into a regional door-to-door transit system can significantly increase water crossing capacity for commuters. However, to realize this potential, the ferry industry must meet several challenges associated with growth, including environmental impacts. In particular, concern over air pollution emissions from marine engines is motivating new comparisons between ferries and other transportation modes in terms of both mobility and air pollution. Eco-friendly fuels that give off fewer greenhouse gases play a key role in reducing air pollution caused by ferry traveling. Liquefied natural gas has started to be used as a fuel in ferries. It is a non-toxic liquefied fossil fuel that mainly contains methane and significantly reduces carbon dioxide emissions in compared to diesel. Its costs depend on the price of natural gas, the liquefaction, and the transportation. Ultra low sulfur fuel oil has been trying to make its way into the ferry industry. It's a type of fuel consisting solely of distillates of crude oil, and its sulfur content is a max of 0.10%. Until now, it has mainly been used in auxiliary engines. Even though the emissions of this fuel are considerably lower, its price is almost double that of regular diesel fuel. Biofuels are one of the most prominent means of reducing the carbon footprint of ferries. Biofuels are derived from biological waste, mainly from agriculture, and depending on the type of biofuel used, carbon dioxide emissions can be reduced by 80 to 90%. Apart from opting for more environmentally friendly types of fuel, ferry companies have been making efforts to equip their vessels with new technologies that can save up energy and restrict water and air pollution, such as technology for advanced engines, filters, combustion engines, propulsion engines, propellers, and hull coatings, electricity consumptions in the form of marine solar panels, energy-saving LED lighting, and energy-efficient motors, water waste, the biological treatment of sewer waters, filters for gray waters, non-toxic cleaners, treatment of water waste from machinery, and finally solid and plastic waste, recycling, managing of cargo residues, introducing e-tickets in order to reduce plastic ferry tickets. There are several trends that are upcoming that will look to help our transportation needs into the future, including the following. First, electrification. When it comes to cars, electric vehicles appear to be reaching a tipping point. As of 2020, electric vehicles accounted for just 6% of global automotive sales, but that is projected to grow 13% by 2025 and 22% by 2030. Second, autonomous connected vehicles. Autonomous vehicles provide an incredible opportunity to revolutionize the way people and goods are transported, improve road safety, and ease congestion on our busy roads. They may even change the way our cities are built. If you can think about it, huge parking lots will be a thing of the past, as driverless vehicles will be able to drop us off at our destination and come back for us later. Finally, servitization. Increasingly, there will be a mobility as a service or MaaS providers to meet our transportation. Think of MaaS as a mobility on demand. A company like Uber could technically fall under this bracket, but MaaS operators of the future will offer customers multiple mobility options via a single payment channel and interface.